Net Yaroze has died. After a long life of presumably sitting on someone else's shelf, this unit died on me shortly after I bought it, and sadly a replacement is just a little bit out of my price range. The Net Yaroze is the consumer version of the PlayStation development kit. Born in celebration of the first indie developers in the UK developing on the home computers of the early 80s, the Yaroze was the first, and one of the only, attempts to democratise game development on a major platform. The Yaroze isn't a true dev kit. You couldn't burn your creations to a CD and distribute them. While some games were deemed good enough by Sony to include on a special edition release, and were subsequently enjoyed on demo discs on retail consoles, the primary way of distributing them was simply by sharing the build online, where it could only be played by other Yaroze owners. Additionally, while the Yaroze SDK contained most of the official PlayStation SDK given to partners, there was one major limitation. The entire game had to fit inside 2 MB, the size of the PlayStation's memory. The games people created ranged from simple platformers to 3D racers, limited only by the programmer's skill and imagination. But underneath the custom black shell and the fancy included hardware, there's not really anything special. It could play retail games, and on the back seems to just be a regular PlayStation. Which got me wondering, can we build our own Net Yaroze? Let's find out. First, what makes the Yaroze different? PS1 motherboards have a special chip on them called the Mechanics Controller, or Mechacon for short. This chip instructs the laser to read a specific wobble on a PS1 disc, which contains the licensing data. Technically, a PS1 can read games from any region without much issue. There might be some desync and rhythm games, but that's about it. The specifics of region differences are surprisingly in-depth, so feel free to comment if you're interested in a video on that. But for our purposes, the wobble encoded a short string that denoted the region, and the Mechacon wouldn't approve boot until it found its specific region code. PlayStations in Japan look for the SCEI string, while America and other NTSC regions had SCEA, and PAL had SCEE. The Net Yaroze didn't care what region code a disc had. It was the only retail version that was region free. Because of this, Yaroze boot discs were pressed with a special region code, SCEW. This code prevented the disc from being booted on traditional retail consoles. The sharp among you will have realised where this is going. Before anything else, we need to get our console to ignore region codes. The way to do this has been established for a while now. Mod chips, or tools like FreePSX boot. At this stage, it's worth mentioning, not every model can be turned into a Net Yaroze. The original Yaroze was based on the SCPH-1000 series, so has all the classic I/O options. After the SCPH-7500 series, the parallel port was removed, and the slim PS1 got rid of the serial port. There's a few internal hardware differences between the models that are for another video, but to build your own Yaroze, you need, at the latest, an SCPH-9000 series with a serial port. For this build, I'm using an SCPH-7502 and installing a mod chip. Note that there's a massive heat shield on this model that you'll need to decent time with enough heat to remove, and also remember that metal conducts heat, so if you're working on one of these later models, be careful not to burn yourself like I did. You can skip mod chip installation if you get a free PSX boot memory card. Next, we need a way to plug the PlayStation into our computer. The original Yaroze came with a cable to do this, and used the RS-232 protocol with a few minor modifications. The main barrier is the use of a different voltage. If you're somehow able to get one of the original cables, all you need is a way to plug it in. StarTech makes PCIe serial cards if you don't have a computer old enough to include one already. If you don't have a Yaroze serial cable, you're probably not going to be able to buy one. An alternative is the GameShark link cable, but those are equally rare. So we need to build our own. Luckily, serial is still used in quite a few things, and a little chip exists to help us. The FT232R handles voltage conversion and lets us connect to a modern PC with USB. I should note here, if you're going with this method, please make sure you get a genuine FT232 from a reputable supplier. While I don't share the xenophobia ingrained in a lot of Western internet users nowadays, I've not gotten a good chip from either AliExpress or Amazon. Stick to Farnell or Radio Shack for buying this. It'll be more expensive, in the region of £15, $20, but it'll actually work. You'll also need a boot disk for the Yaroze. These are also exceedingly rare, but luckily if you have a blank recordable CD somewhere, this is less of an issue. There's a modified version floating around that bypasses the need for the special access card, but I can't link that here lest the YouTube gods smite me for my hubris. Just make sure to use a CDR rather than a CDRW. The PS1 laser doesn't like them very much. The next hardest part to get is a link cable. To build our own Yaroze cable, we need to hack one of these apart. These are also becoming rare, but are still moderately available. I should note here that if you want to build a full dev kit, I'll cover ways around this problem in a future video. The Yaroze is somewhat limited in capability and a full toolchain can help us make more complex games, but that's a different project. An official link cable is best since it's guaranteed to have all the wires in it we need, but third-party ones exist too. On the bright side, you get 2 tries to do this part right. Hack it apart and strip the wires. There should be 7 wires, and if you're using a third-party cable, possibly some shielding that acts as grounding. The colours will be different between cables, so we now need a multimeter to figure out which pin is which cable. Don't worry too much if pin 2 and 7 don't connect to anything. Pin 2 is ground, and we don't need pin 7. Some third-party manufacturers incorrectly run this to ground. From my post-it diagram, we can see what each wire is. We can now solder these to the FT232R, but be aware that this requires a very steady hand and some patience. I'm going to cut the video here because I needed to get in close to see what I was doing and huff some lead fumes, but the key here is patience. Have some solder wick on hand to undo any mistakes, and don't worry if it takes a few tries. Now we need to configure it to be able to communicate with the Yaroze, so let's go ahead and open FTprog. I've included a link in the video description. If we hit the search button, we get a device. This is an FT232H, which isn't what we're using. Most likely this is something on my motherboard, probably an RGB controller. So we'll ignore that and connect the one that we are using. Hit search again, and now it shows up. If we select it, we can see it's the FT232R we want. So to make the adjustments we need, hit the hardware specific tab, invert RS232 signals, and the 4 boxes we need to check are invert RTS, invert CTS, invert DTR, and invert DSR. Then click the lightning bolt up top to open the programming dialog. Make sure any devices we're not using are unchecked, then program. It'll only take a few seconds. While I'm here, I want to quickly show you what happens with a knockoff chip. So let's take our real one out, put the cheap one in, and rescan. We can see that it shows up as an FT232R, but if we go to invert the signals and reprogram it, we can see that it went much quicker. If we rescan again, nothing happened. We can see that the changes don't stick. If we swap back to the real one and scan, we can see that they did stick on the real one, so we can go ahead. If we look in Device Manager, we can see that my computer already has a bunch of COM and LPT ports. Some of these will be the PCIe card I installed to provide those, but some others are part of the motherboard. This might be, for example, RGB controllers, BIOS flashback, or even that annoying thing some motherboards do where they try to install their bloatware on a fresh Windows install. This shows us at least the current port numbers. We can see I have 3 serial ports, so if we go ahead and connect the FT232 and refresh, now I have 4, so we know it's been picked up and Windows has given it a port number too. So, that means we can start getting things hooked up. The next stage is the same whether you're using the real Yaroze cable or whether you've made your own. However, we have a slight problem. The Net Yaroze tools were designed for DOS, and some of them are 16-bit only. We can't run them on a 64-bit operating system, and community experience shows anything after Windows XP has some issues. We can get around this, and it'll even treat your USB cable as a real serial cable. There are two ways to do this: emulation and DOSBox. I recommend the DOSBox method, but if you're someone who fancies a challenge, I'm including the emulation method for you folks. It's ultimately preference. DOSBox will work most of the time, but there might be a couple of edge cases where emulation might be better. If you just want things nice and easy, skip ahead to the DOSBox chapter. Otherwise, allow me to introduce 86box. 86box is a utility designed to emulate legacy hardware, in the same way that a console emulator mimics the hardware precisely of a retro games console. You'll need three parts for this: 86box itself, the ROMs to use for it, and 86box Manager. I've included links to all of these in the video description. You'll get a warning if you're launching 86box Manager for the first time. Just ignore it. Hit Settings up top and point it towards your 86box installation. Now, let's configure a machine to emulate. 86box emulates hardware precisely, so we don't need to go too powerful, just something that's capable of running the version of Windows we're choosing. For this, I'll be going with Windows 98 since it's DOS based, but 95 and XP should also work. 86box can be confusing with all its options, and legacy hardware was confusing itself, so don't worry if you feel overwhelmed, feel free to just copy what I'm doing. First, add a machine and give it a name. We want to configure it before it starts, so check that box as well. 86box accurately emulates the hardware of the time, but this uses a lot of CPU power. Think how slow certain emulators are on modern hardware for even old consoles sometimes. With this in mind, we want to use the simplest hardware that meets our purposes. For the sake of not being too awful to configure, we'll go with a Socket Super 7 Pentium CPU at 133MHz with 64MB of RAM. The machine dropdown can be left as whatever, as it doesn't make much difference for our purposes. On the display tab, we need to configure a GPU to emulate. I'll go with an S3 Verge. For input devices, we need a mouse, so set that to standard PS2 mouse and configure it to be a wheel mouse so you don't hate yourself later. The PS2 mouse is important. A serial mouse can interfere with the RQ settings for the serial cable we're using. On the sound tab, set sound card 1 to a Sound Blaster 16. Network is up to you, but I'm configuring one so I can access my local file shares. Set the mode to Slurp and choose one of the PCI cards. I messed up on this bit, don't use an NE2000. On ports, we finally get to pass through our Yaroze. Uncheck serial port 2 and check serial pass-through 1. Hit configure and change the mode to host serial pass-through. For host serial device, set which one you think is the adapter you're using. I'll show you how to find this at the end of the video. At this stage, it's worth noting, if you're using the FT232 method, Windows might have pushed down existing COM ports a number, so you might need to experiment a bit with passing through the right port. For storage controllers, standard IDE controllers should be enough. On hard disks, create a hard drive. 1GB is plenty. Set the type to custom large, type 1024MB, and it'll configure the rest automatically. We also need a floppy and CD drive to mount our Windows ISO and boot disk, so create a CD-ROM drive on the AT-ABI bus and a 3.5-inch floppy drive. Finally, hit OK to configure the machine. Start the machine, hit Media up top, hover over the CD-ROM drive, and click Image to find your 98 install ISO. Do the same with the boot floppy. As with all legacy hardware, there's some annoying setup to do. Go to Action, Hard Reset, then click in the window mashing Delete to enter the BIOS. In PMP and PCI setup, set PMP Aware OS installed to Yes using Page Up. Hit Escape to back out. Then in BIOS Futures, set boot sequence to A CD-ROM C, again using Page Up a couple of times. Back out again and use F10 to save. Now it should finally boot from the install floppy. Installing Windows is pretty simple, so go ahead and do that at your leisure. On the View menu, you can set the dimensions of the window, I chose 1280 by 1024 and locked it just to give us a nice big screen. You can, of course, save yourself the hassle of 86box if you have an older computer lying around. For AMD, socket AM3 and earlier support Windows XP, and for Intel, LGA 2011 and LGA 1155 work, though these may or may not have serial ports. Things that are a little older, say before 2010, you should be able to run Windows 98 as well if you limit the available memory. Generally speaking, if a board has a serial or parallel port, it'll work just fine. Something to bear in mind is that this era of computing still used IRQs. Serial ports typically get either IRQ 3 or 4, which is the default in the Yaroze SDK, so we probably don't need to change anything, whether we're doing this in 86box or on a real machine. I do most of my experiments on a real machine and it is how I'd recommend it. But I also completely understand how hard they are to get a hold of, which is why I'm showing you this way. Once installed, download the SDK linked in the video description and extract it somewhere. Mount the folder you just extracted as a CD drive, and copy the PSX and GNU folders to your C drive. To use them, we need to open a DOS prompt. First, we need to check the presence of a line in c:\config.sys. We need the line device high equals c:\windows /command /anc.sys. If it's not there, add it and reboot. cd to your PSX directory and run djsetup.bat to set the environment variables. Now we'll look at DOSBox. The DOSBox way is probably easier, less taxing on your computer, and has the advantage of working on a 64-bit PC too. DOSBox can simply be installed and will give you a DOS environment. It needs a little configuration though, so head to the directory you installed it and run the options batch file. This will open a text file. Scroll down to the section headed serial, change serial 1 to read serial 1 equals direct serial realport equals COM2. Obviously change COM2 to whatever serial port you're using, I'll show you how to find this in a moment. Then scroll down to the autoexec section. Download and extract the Yaroze SDK linked in the video description to a folder on your C drive. Here I'm putting them all in a PSX dev folder which has the 4 folders in it. Under autoexec, we want to mount this folder, so add the line mount c:\psxdev to mount the contents of this folder en route. Under that, we want to set the environment variables, so add the line c:\psx /djsetup.bat. Finally, add c:\/ to automatically change to the SDK root folder and save it. Open DOSBox and you'll see that these commands are run. Sometimes changing to C doesn't work, so do this manually. Now we're finally ready to test the connection. Put the boot disk into your console and wait until you get the brick screen. In your DOS prompt, whether it's DOSBox or a command shell, type cd psx/bin. Then type cyocons and run it. This is the basic interface for communicating with the Yaroze. Press escape to exit, then type cd /quick. There's some useful test programs in this folder that we'll use to check the connection. Type cyocons batch 0. You'll likely get an error saying that tuto0 not found. So let's fix this. Hit escape to exit cyocons and type make. You will probably get another error about not being able to open a swap file, so make a folder in the PSX dev folder called tmp. Run make again, and we see access is denied, so right click the tmp folder, hit properties, security and edit. We need to add a group called everyone. Type that in, hit check names to validate it, then give it full control and save. Back in DOS, type make again and it'll now compile the example code. Make sure your new DIY Yaroze is running, and now finally type cyocons batch 0 again. in the console and on the console, we'll see it transferring. When done, your TV should show a lovely, simple message. Hello world. If you exit this and reset your console, batch 1 will show Hello World in the DOS prompt instead, demonstrating the debug output futures. Congratulations! You now have a Net Yaroze of your very own. As a final tip, to find your COM port, use PuTTY. While mostly used for SSH, PuTTY lets you communicate over serial interfaces too. Simply select the serial option and increment COM ports until you reach a prompt mentioning CIP version 2. You can verify this is the PlayStation by simply sending the question mark command, which will list the available tools, as well as tell you it's the PlayStation. Once you know the COM number, you can pass this through to 86box or DOSBox as needed.